Problem number 10, f and g are continuous functions on the closed interval from 1 to 4, and some values are given. We have to use the tables here to answer all these parts of question 10. Part A asks, is g prime positive, negative, or equal to 0? Well, let's look at g. As x increases from 1 to 4, g drops from 16 to 12 to 8 to 4. So the values of g are decreasing. If the function is decreasing, the derivative is negative. Next we are asked, is g double prime positive, negative, or equal to 0 on the closed interval? Well, in order to look at the answers here, we have to look at how the change is changing. G prime looks at how the function is changing. Oh, the function's decreasing, so g prime is negative. Now we have to look at how the change is changing. So let's look at the change. The first change we had was from 16 down to 12. That's a change of negative 4. The next change that we had was from 12 to 8. That's also a change of negative 4. Finally, we have the change from 8 to 4, which once again is a drop in 4 units. So how is this change changing? That's right, it's not. There is 0 change in the change. G double prime represents how the change is changing. There is no change. It is equal to 0. So g double prime would be equal to 0. Let's look at this another way. Let's draw this on the graph. Okay, make a quick graph. Over 1 up 16. Over 2 up 12. Over 3 up 8. Over 4 up 4. Graph that line. The key thing is it's a line. There's no curvature. The second derivative is concavity. That represents our curvature. There is no curvature, so the second derivative is 0. Last but not least, f prime, we're told, is positive, and f double prime is negative. So let's put some possible values for f in the table. We're doing the reverse of a and b. We know that f prime is positive. This tells us that our values are increasing. A positive derivative means an increasing function. F double prime is negative. This means that our change is decreasing. So while the numbers have to be getting larger, the rate at which the numbers are getting larger must be getting smaller. All right. So let's pick a number that's larger than 1. I'm going to use 6. There's an infinite number of answers that you could put in here. It does not have to be 6. But watch what I'm going to do here. The change from 1 to 6 is an increase of 5. That's good because we have to have an increasing function. Now, the change must be decreasing. So when I do my next change, I cannot increase by 5 or more. I have to increase by less than 5. I'm going to increase by 2. Right? 2 is less than 5, which would mean that I would now have an 8 right here. I could have also increased by 3. I could have increased by 4. I could have increased by 3.5. There's no rule that says that we have to have integers right here. So I just have to have a change which is positive but decreasing. Okay. So let's have another one. I need a number smaller than 2 that's still positive, so let me do 1.5. And so my third value would be 1.5 more than 8, or 9.5. Again, these are just sample ones. Yours can be entirely different than the 3 that I placed in here. But the numbers should be increasing, and the rate at which the number is increasing should be decreasing.